Okay, we are looking at kinematics, which is a fancy word for objects or particles or bodies that are set into motion. We're going to look at some basic concepts, and then in the videos to follow we'll look at several examples. So we're going to first define our variable s as our position function with respect to time t. So t is like what x usually is in a traditional equation. When we talk about motion problems, we are doing this with respect to time, so t is our independent variable. The term displacement refers to our change in position, and to find our change in position, we're really talking about delta x. It's really just s of b minus s of a. We're talking about a and b as 2 points in time. If a is our starting time and b is our end time, we're simply going to subtract s of b and s of a to find our change in position. So it's the ending place minus the starting place. In other words, your ending position minus your starting position. Now, if a particle does not change direction, then we say that the displacement is going to be the same as your total distance traveled. So your change in position, where you ended minus where you started, that would be the same as your total distance traveled if there's no change in direction. Alright, let's talk about velocity. Velocity is a vector, which recall a vector is a quantity that has both magnitude and direction. Let's talk about the direction piece first. The velocity is telling us the direction of our motion. If we are moving forward, it means we have a positive velocity. And if we are moving forward with a positive velocity, it means the distance away from where you started is increasing. So we say that s is increasing. If we're moving backwards, it means we have a negative velocity. And if we're moving backwards, then our position s from where we started would be decreasing. So keep that in mind. That's the first part of our vector definition for velocity. Okay, it tells us the direction. And then we also have, with that, speed. Speed is defined as the absolute value of velocity. All right, this is the magnitude part of our definition. So we could say things like a car is traveling on the thruway with a velocity of negative 75 miles per hour. Well, that negative part means that it's given us the direction. So perhaps it means it's traveling west. The speed is not negative 75 miles per hour. Of course, the speed would say, or would be, just 75 miles per hour. So the sign, whether it's positive or negative, tells us if the particle is moving forward or backward, and the absolute value of the velocity gives us our speed. Okay, a few more concepts centered on velocity. So let's talk about average velocity. Okay, average velocity, which we can use this little sub-AVE notation. This is defined as our change in s over our change in t. In other words, it's our change in position divided by our change in t. So it is like an average rate of change. Okay? If we're looking to find an average rate of change, we need to figure out what our change in position is and then divide it by our change in time. Okay, so that's average velocity. And again, we'll see an example shortly. Instantaneous velocity, this is the velocity at any moment in time, and we use v of t to represent this type of velocity, and this is defined as the derivative of our position function. So make the connection before. We talked about how instantaneous rate of change is really a derivative, and so we can write it a couple different ways here. Okay, so it's the derivative of our position function. A couple other points here to make. When the velocity is equal to 0, so it's not positive and moving forward, it's not negative and moving backwards. If the velocity is equal to 0, it means our particle is at rest. So for a moment, it stops. Okay, it's not going forward, it's not going backwards. So to take this a step further, if our velocity is equal to 0, so the particle stops for a moment, and the velocity changes sign. So you go from positive to negative or negative to positive. So in other words, you're going from moving forward to backwards or from backwards to forwards. What's happening here is that the particle is changing direction. So if we're trying to figure out where a particle is stationary or at rest, you're going to set your velocity equation equal to 0 and solve. If you're trying to figure out does it actually change direction, you got to look at the signs for velocity on each side of that point. Okay, our last concept is acceleration. This is another vector. So acceleration deals with measuring how quickly a particle picks up or loses speed. So acceleration, we tend to only talk about instantaneous acceleration. We don't really get into average acceleration. If we needed average acceleration, it would be just like average velocity. Average acceleration would be change in velocity over change in time. But again, we tend to focus on just instantaneous acceleration, which we use a of t to represent that. Well, this is going to be the rate of change of the velocity. So v prime of t, so it's the derivative of the velocity, which means it's also the second derivative of our position function. Now understand what it means if our acceleration is equal to 0. It means we have constant velocity. And if we have a constant velocity, it's kind of like setting the cruise control on your car. Okay? You're not speeding up, you're not picking up speed, you're not losing speed. You're maintaining a constant velocity. Now, these last 2 points here are really important. If acceleration and velocity have the same sign, so meaning they're both positive or they're both negative, this means that they're both pointing in the same direction. So both of those forces are aimed or pointing in the same direction. If that's the case, then our object is speeding up. Compare that to when an object is slowing down. We're going to slow down when our acceleration and velocity have different signs. So one's positive, one is negative. This indicates that these forces are moving in opposite directions. If they're moving in opposite directions, then the body is slowing down. So don't think that just because you have a negative acceleration, that does not mean that you're guaranteed to be slowing down. You could have a negative acceleration and a negative velocity, and in that case you would be speeding up. Okay, and lastly, we have a term here that's not used that often, but we have the term jerk. Doesn't mean when someone's being a jerk. It's the other connotation, like when you're traveling and it's a very jerky ride. Well, a jerk is a sudden change in acceleration. A jerk is what spills your drink, right? That sudden change in your acceleration. This is the derivative of the acceleration, which means it's the second derivative of velocity and the third derivative of our position function. Again, it's very rare that you're going to see this used. This is probably more of a nice to know as opposed to a critical need to know.